This is TempleOS 5-Minute Random Code Walkthrough, episode 102, and I'm your host, Terry Davis. And God took us into the sprite code, sprite type mask. Okay, so the sprites are a internal data structure for vector graphics, and what they are is a series of okay, so you can have a color, a dither color, a width. You can set up planar symmetry. These are in order. These are an ordered sequence of vectors. Do a line, a polyline, a rectangle, etc. Okay, so each one of these has a raw binary format. This is a point. No, this is a point. So it starts with one point and then it adds a second point. That's for planar symmetry. A line is a point. Let's see, how about an ellipse? An ellipse is a width, height, angle. So these are the sprite element types. And if we go back to sprite type mask, what this does is it constructs a bit mask of all the element types that are present. So first of all, there's two ways you can point to an element. You can either point to a Q version with the Q links for a circular doubly linked list, next and last. Either you can point to the Q, or you can point to the binary data portion. This is a bunch of raw binary. It's a byte code, I guess if you want to call it that. It's byte code. So you can either point to the Q, that's when they're being edited, or you deal with the raw binary when it's being displayed. So it's a whole bunch of independent nodes when they're in a queue, and they're concatenated together as raw binary into byte code. So this subtracts off the Q links. So you pass it a raw binary, and it basically converts it so that it can the Q links. Anyway, so while it's not the end is a 0. This is basically checking for a corrupted value. It returns a sprite element. If it's corrupted, it returns corrupted. That's what that is. Otherwise, it bit test and set. The TempleOS bit instructions are the same as x86 assembly. Bit test in complement, bit test in reset, bit test in set. So you pass it the address of the result integer. So obviously we can only have 64 types if it fits in one 64-bit integer. But if I had made this into, let's say, an array of 4, we could pass it the address of the array and it would work. It's not limited to 64 bits, the bit test and set. And then we typecast to a size 1 for pointer arithmetic, and then we do sprite element size. We add sprite element size, and sprite element size uses the base sizes, and then some of the elements are variable width, like a bitmap is depends on the width, height, and so forth and so on. Anyway, so now where is this type mask used? Well, your best friend is to find sprite type. I didn't make that public, I guess. Oh, I think that makes sense. Anyway, it's used in the, it's not used in very many places. It's used in the, when it's updating a doll docs document, it checks the, it collects an ORed image of all the bits, and if it's flood fill or flood fill not color, then it treats it differently if it's flood fill. And the other thing it does, where is this? This is order 1. Oh, if we get an invalid type, then we substitute the empty sprite image. Okay, so flood fill causes it to not blink. I think so. Is that all it does? Okay, so if you do Control R and you do make sprite, we can draw lines. And let's exit sprite. Now if we're on top, it blinks. Now if we do a sprite with a flood fill, let's do a circle, ellipse, whatever. There's the angle. Let's do dither color. Flood fill. Okay, so the difference is when it's displaying the command line document, if you're on top of the first sprite, it blinks. If you're on top of the second sprite, it doesn't blink. That's because of the flood fill. Anyway, that seemed to be important to me. I think it's inverting the colors, and that's how it's blinking. You can see if we zoom in, Control Alt Z, when it's blinking, it's using white and black there. Control Alt